Alright, how's it going, y'all? Today I've got a video I'm actually really excited about because it's how to turn any Raspberry Pi into a remote monitor and shutter release for basically any DSLR or mirrorless camera, as long as it has an HDMI output and a shutter release. And it's incredibly easy and works so much better than those web interfaces that just do not work that well. And it allows you to see your screen, as well as fire the shutter or even focus. And overall, it just works incredibly well. It's so much better than the clunky apps that these manufacturers always have, and it allows you to have as many cameras as you like on your network, and all being able to be accessed separately. So if you were something like a video production house and you had a bunch of cameras going, you could access every single one of them individually, which is so much easier than trying to hook them all up into a relay system. This can be great if you want to remotely deploy a camera and be able to fire off the shutter without being around and just monitor it from your laptop. And so the way it works is incredibly easy. It's powered by TinyPilot, who sponsored this video, and it essentially just combines a HDMI capture card. So this captures the HDMI signal out of your camera and puts it on a web browser, and combines it with a remote shutter release like this. So this is a cheap remote shutter release that you press, and it would remotely activate the shutter. And you essentially just combine these two things together with TinyPilot, and you've got yourself any DSLR, mirrorless, or even some point-and-shoot cameras being able to be controlled from your web browser with both the shutter and seeing the actual viewfinder. And so it's just got so many versatile applications. And so the way this all came up was I was talking with Michael, the owner of TinyPilot, and I realized the perfect application of his system, which essentially allows you to control any computer, would be to also allow you to control any DSLR using almost the exact same format, just switching out the remote keyboard input for a remote shutter release. And so it just pairs really nicely. You're capturing the video and being able to see it on the monitor. Then you use the GPIO pins and a relay to open up the shutter release, which is just the same as clicking a button with a remote shutter. It's just closing the circuit, and that's as simple as this build is. And if enough people are interested, Michael's also going to build an all-in-one solution that is really easy and will hopefully stick on top of the hot shoe of your camera and allow you to just have two cables in, an HDMI cable in and the remote shutter cable in, all without having to build the circuitry yourself. And so if you're interested in that, there's a link in the description and you can sign up to get notified for it and show that you're interested in the build. And so installation is an incredibly simple one-line code that I'll leave a link to in the description below. YouTube does not like it when you put code in the description, so I'm going to leave a link to it. And then after that, it's really easy to set up. You do have to build a circuit right here. So this is essentially the circuit that goes through and takes GPIO input and turns them into relays, which then goes through and has an output for the pins. And I'll go through and show the wiring diagram, and I'll leave a link to this in the description below. But it's actually really simple, and this is just a prototype. Michael will be building a all-in-one solution if he gets enough interest, and so that link is in the description below. But this essentially allows you to go ahead, and anytime one of the GPIO pins is turned on, it will close the circuit, which is the same thing as pushing the button on a remote shutter release. And then for capture, we've got this right here, which just takes in any HDMI signal and puts it into the TinyPilot video stream. And so once we've got these two things set up, we can go ahead and just plug it into our camera and go ahead and have remote access to the entire thing on the web browser. All right, and so as you can see right here, I've gone ahead and plugged in the two cables right here into the Raspberry Pi. And now if you look at my screen right here, boom, we have full access to the camera with actually really low latency. And so it's really easy to set up from here. So as you can see, I've got the full display from the output of the camera, so you can see what's going on, and it's incredibly responsive. And so to set up the actual camera controls, there's just two simple options right here. You say which pin is on the autofocus one, and so that's plugged into GPIO pin number 2 for me, and then the shutter is on GPIO pin number 3, and that's what those relays are on. And so then down here, you can see right here, there's this focus on shutter toggle that you can hit. And so what that does is it fires both the shutter and the focus anytime you hit the shutter button. And so the reason that's important is Nikon's a little bit weird. Canon and everybody else I know does it differently, where Nikon requires you to have both the focus and the shutter pins as down if the shutter is going to release. And so this basically just goes through and fires both of them off at the same time, so you don't need a diode. And so it's incredibly easy to do. You can just hit autofocus and the camera autofocus. And so we just fire. And just like that, you can keep firing off images remotely, incredibly easily with really low latency. and it works really well. It is so much easier than trying to use the built-in applications and trying to connect them to Wi-Fi when they just don't work that well in my experience. And this will work backwards compatible because just about every single DSLR has both these requirements. And it is just so easy to set up. I'm really impressed by this, and the latency is awesome. You can see I'm moving it around now, and you get the signal back ultra quickly. You could even use this to help focus assistant, and the image is just so much clearer than the ultra pixelated version I've seen with some of these cameras. Even my Canon has not nearly this nice of an image output when I'm connected to it over my Ethernet connection. And so really, that's all there is to it. Now you've just got your two cables going off your DSLR right here, and it's transmitting the video and that shutter release that you can easily go through on your web browser and connect to and fire off everything. All right, and so now for those interested, I'm gonna go ahead and walk through how you build this at home, and it's actually pretty easy if you know a little bit about electronics. So you do need an HDMI cable for your camera, and so every camera is going to have a different HDMI output. Just make sure to find the one that's right for you, and you're going to need one of these HDMI to USB capture cards, and you just plug these two in together into the Raspberry Pi, and TinyPilot handles the rest for that. Then for the remote shutter release, you're just going to need a couple of wires, a remote shutter for your camera. These are really cheap, and you can buy the cheapest one possible because we're actually going to be cutting it up, and then just a couple of relays right here. I know this looks like a mess right here, but really all these relays are doing is they're acting like this remote. So when you press it halfway down, it's going to fire off the remote focus pins. Then when you press it all the way down, it'll fire off the remote shutter pins. And that's all there is to it. All relays are doing is completing a circuit. And so what you do is you just take the cable that came with the remote shutter and you cut the end off and basically figure out which wires are the ground, focus, and shutter. And then all you have to do is plug those two in and set them all up. You want to make sure that ground goes in between both two of them, and that's really all there is to it. Then whenever you fire off the shutter pin, the shutter circuit will be closed. When you fire off the focus pin will be closed. And that is just the same thing as pressing the button, and so it will tell your camera to fire the trigger. And so then on the other side, we've got the actual relay's power. So it takes two power inputs, plus and minus, and those are easy enough to do. And so these cables that go across the two of them are just to make sure they share. And then I've got two cables right here that go into the GPIO output. And so the GPIO output are those two pins that you want to set up. 2 and 3 work great. It's super easy to set up, and you can just do it on a Raspberry Pi display. And so what this does is whenever the pins go high, which is when you press the shutter button, it will close the circuit and act like you press the button. And that's really all there is to it. And so then on the back right here, I've just added in a little bit of strain relief so that the cable does not get ripped out over here. And really that's all there is to it. You just need to go ahead and hook this up to a Raspberry Pi, and you'll be able to download the TinyPilot software with the one-liner command that's in the description below. Now obviously this is very much in the prototype build phase, but it will work for you, and because the remote shutter release cable is long enough and the HDMI cable is long enough, you can just set this on the ground or somewhere else, or put it in like a little build box so you don't have to have it all flopping around when your camera's on a tripod. Now, if you want a pre-built package that has everything in a nice box and everything like that, I would not blame you. This is still in a bit of a prototype phase, but Michael is planning on building one of these and selling it where it's just a simple pre-built package that will be able to stick in your hot shoe if he gets enough interest. So go ahead and check the link in the description for that. And that's all there is to this tutorial. Go ahead and leave any other tutorials you'd like to see me make in the comments below, and have a good one. Bye.